Hello, everyone. Welcome to this session, Containers and Kubernetes on AWS. I'm Ramesh Dwarakanath. I am a solutions architect at AWS. Now, all throughout the day today, right, you've heard about containers and Kubernetes in different contexts. You already know the advantages the technologies bring to the table, right? These two technologies bring to the table. In this particular session, we'll talk about running them on AWS and what AWS provides to enhance that experience. Now, when I started to put this presentation together, there were two perspectives on this, right? Either I can talk from an AWS service detail point of view, saying, hey, what AWS offers in the container space, and there is a lot that we offer. And we can talk about different services and so on, right? The other aspect would be talking from a customer implementation point of view, right? Taking some customer examples and seeing how they are actually using the AWS services, container services. Now, I think looking at both, and both are actually equally important, right? But I just felt that talking from a customer point of view was probably more interesting and relatable to the crowd here, right? So this presentation is focused on how our customers are using containers and Kubernetes. Okay. So the agenda, what I'm going to talk about today is why companies are moving to containers. And I'm not going to just give you some high-level points around that. What customers are building on AWS. Obviously spend a lot of time here. We'll look at some select customer examples and talk about what they're building. We'll not be able to go into too much of detail into each customer, but these are all publicly available, and I'm more than happy to provide the links if people want to reach out later. We'll see how customers are building on AWS, right? And as I mentioned, and as Murthy also mentioned in the previous presentation, that there are a lot of AWS services in the container space, right? But today we'll focus primarily around Kubernetes and EKS, right, which is our managed Kubernetes offering for this session. Okay, so what are our customers asking for, right? And what do our most successful customers want from us? What lets them innovate quickly, compete in a global market, and deliver value for their customers? They want their teams to focus on delivering applications as rapidly as possible. They want their infrastructure to be reliable, highly available, secure, and cost efficient, most importantly, and customized to their needs. They want a proven track record of scaling to whatever size they need and to scale up and down rapidly. Right? That is really why a lot of times, one of the driving factors to move to cloud is the scalability, the elasticity of the infrastructure that is available to you, so that you only pay for what you consume or what you use, right? And they want security and isolation. That goes without saying, right? So security is heavily on everybody's minds, no matter where they are, what environment they're in, and especially when they get onto the cloud. They want to make sure that they have security, isolation, and control over the access and permissions, and they want automation to reduce human error, right? So you don't want, and that's traditionally been a problem. People end up doing manual work, and then there are manual changes, they're not tracked, or it becomes each becomes a customized change, and so on, and that invariably will lead to errors at the end, right? So we want to have complete automation to manage all that process. So because of all of this, right, we have seen a large push towards containers. And what we are seeing is, we are seeing some uniform security across the environment, which is maintained with automation, right? Because the whole way you're packaging everything in a container, you're deploying it in an automated manner. So you're obviously overall, there is overall automation in the build. It's consistent and standardized. That's why, in turn, you get reduced risk. You want operational efficiency. right? You want to be able to take away that undifferentiated heavy lifting. And this will be a theme that we'll talk through for the rest of the session as we go through it. But that is something they want to get, right, to reduce their operational burden. They want to be able to move faster. They want to have, a consistent environment, and basically that improves the agility, and obviously that leads to, innovation and so on and so forth. And again, the whole automation aspect of it is, again, you test more, you iterate faster, you fail fast, you figure out, okay, that's not right, and then you're able to go through that fairly quickly, and then what comes out is a very well tested, thorough product at the end. So what are our customers building, right? So what we have seen is they're building their most sensitive, secure, and business critical workloads on AWS container services, right? And container services, as we have seen, they are core to our customer strategies. So what exactly are they building? So they're building applications. What does application mean, right? They are building, customers are building the backend services, including platforms that power their IT organizations and the consumer applications that drive their top line growth. Many of the customers build shared services platforms to help their dev teams move faster. These platforms automate software deployment, infrastructure provisioning, and then also provide guardrails for management, security, and governance. Some of the other customers are containerizing their legacy .NET, Linux, Java applications and moving them to AWS. Containerizing that has become one of the fastest ways to actually make that journey from your on-prem, from your legacy apps onto the cloud. And then using what Murthy had mentioned, the triangular pattern, you can actually just peel away, add that, and then start to make, go into more of microservices approach, right? And then finally, machine learning is actually a very, very large and growing use case for us as well, right? Things like autonomous vehicle workloads, right, is a huge use case for AWS container services. And we have things like recommendation engines, fraud detection, chatbots, all of those have machine learning under the covers running on containers. So here is kind of a high-level overview of the cross-section of customers that use EKS on AWS, right? So what we'll do is we'll actually go through a few of these, a few select customers, and walk through some of their use cases. So let's take some of these, right? So we have Snap, and how they are using EKS, right? They are basically using EKS for scale and performance. Then you have Babylon. Babylon is using machine learning infrastructure on Amazon on EKS with Kubeflow. And what they are really concerned about is the agility and the speed of deployment, along with obviously cost, right? Then you have Fidelity Investments, which is managing large workloads without managing the undifferentiated workload of the underlying control plane. And we'll look at that. And in turn, they're actually managing, able to run large enterprise workloads on EKS. And then finally, and then we have a Delivery Hero, who's, obviously is a delivery service, and for them, cost is paramount, right? So we will take a look at how they are using EKS on Spot instances. And just as a quick recap, quick definition of Spot, in case people are not aware, Spot instances is essentially the excess capacity that AWS has in its data centers. We use that for customers to use that excess capacity at almost like 80 to 90% of the cost, right? There are some caveats, there are some rules in terms of when you want to use Spot, because at the end of the day, if that capacity needs to be brought back in, then we have to collect that, and then basically any instances will have to be given back. but there are specific workloads that are very suitable for Spot. And again, obviously, there's a huge amount of cost savings that you can get with that. So let's talk about Fidelity for a second, right? So the challenge really was that they wanted a platform. They wanted a platform that was that would provide the governance and security for for all their applications, and then build the applications on top of it, right? So they extended, so they used EKS as the underlying service, AWS service, and then built their platform as a service PaaS on top of EKS. They extended that to include governance, security, observability, and so on, right? And it is an extensible architecture, right? And it's supporting thousands of applications and hundreds of DevOps teams, right? So the whole goal was, how do you make it easy for the application teams to develop faster and not worry about the core infrastructure components like security, observability, and governance, and so on. So some of the goals that they had was obviously scalability and agility, right? Faster time to market, innovation, right? You want to spend all your time for the application to be able to build some new new applications that build add business value, are innovative, adding more features and so on, and solving actually customer problems, right? Reliability obviously goes without saying that you want to have highly reliable systems. Cost, in terms of optimization, in terms of you want to be able to charge it back appropriately, so that way you make sure that the right teams are the right usage and the right cost is being allocated to the right teams. And then finally, you have transparency and traceability. So any transaction, again, being a financial institution, that's really important for them. They want to have full transparency, traceability on what the usage is, the assets, the access, deployments, and issues. So why do they want a platform strategy? They want to be able to scale to hundreds of clusters without compromising compliance and security, right? So they want to have this overarching governance around, but they want to be able to scale the underlying infrastructure without worrying about, okay, if I add a new cluster, EKS cluster, what do I do? Is it going to be handled differently, and so on. Ability to enforce maintainable standards uniformly, right? To be able to say, okay, these are whether it is Fidelity's policies, whether it is other security policies, whatever the best practices are, you want to be able to implement that uniformly. Ability to pivot, to be able to change, to be able to do change direction, right? And rolling out new changes should be just like a platform upgrade. Like you have different versions, a new version of an application, or a new version of a tool, or a new version of any of these components that you have. You want to be able to just do like a platform upgrade. And then you have composability and extensibility. You want to be able to extend the platform. You want to be able to have custom resources built on top of it, extend it, and so on, right? So be fairly flexible with the whole platform. So this is a high-level overview of how the platform looks like. You have your application workloads, things like your trading platform, API platform, AI/ML platform. They're all the application layers, and they are under the covers. Now comes down into the core platform features, things like DR, access control, ingress, cluster management. All of those are like basic core features that are built in, that are extended. And then underneath that is actually Kubernetes, and in this case EKS, which is running on top, which is running Kubernetes, and then the underlying infrastructure, whether it is primarily EC2 and I have auto scaling built into it. And again, the thought process here is using EKS as a managed service for Kubernetes, so you don't have to necessarily worry about all that management of the control plane and the API servers and so on. In the case of Snap, they wanted to manage a large set of microservices. So they're moving their applications. They were moving the applications from monolith to microservices, and they wanted to make sure that they were able to add like things like security, observability, and all of these other aspects, right, transparently to the application as these different new and more services get added. I mean, you're talking about running over 2 million transactions per second, and the amount of new services that were coming in, getting launched, new developers, and new services getting added to it. It was adding a lot of complexity. With all of that, right? EKS helped them, almost like a 77% reduction in developer effort. So basically what they built was essentially a service mesh, right? So that is what they were building a service mesh, and essentially it's an infrastructure layer that provides you, provides you your network observability at the network layer. Any communications that happen between microservices, you're able to observe, you're able to govern, you're able to do control things like your blue-green deployment, your traffic splitting, mirroring, failover. So those are also the things like security. Give mutual TLS, or provide HTTPS, SSL traffic, and so on, to be able to provide standardized traffic management and routing policies between microservices, to be able to discover other microservices without really knowing what else is out there in a very standardized, simple mechanism. And then finally, observability, to be able to debug, to be able to figure out where the traffic is going and where the potential problems could be. Some of the components that they were using, obviously EKS was their underlying Kubernetes infrastructure. They were using the Envoy proxy, which is another open source software that actually helps you look at like the traffic routing, the observability aspect of it. It gets installed with your application containers. You have they had a home built in-house app mesh controller, which actually passed on the rules and the routing and everything to all of these various proxies and controlled the overall traffic flow between each other and all and the security policies. And then you had these, they were using Spinnaker for all the deployment orchestration and rollouts. So here it's a high-level diagram of how you have your your switchboard on the left, which is passing on all the routing rules and everything. It's going through. There is Envoy proxy. It's all running on Kubernetes. There are multiple services, service A, service B. They talk to each other via the proxies, and then there is external traffic that's coming in through an API gateway that's also has a Envoy proxy that again manages the security and the all of the policies being enforced and so on. So basically there is a centralized control in terms of how all of these different microservices talk to each other. For the Babylon health, they were using Kubeflow for the on their EKS infrastructure. It's a subscription health service provider. And provides, basically does the text and video messaging through its mobile application. And their piece was, how do you create, they were creating a lot of microservices, and they wanted to be globally available, highly available global infrastructure, and then to be able to deploy that as quickly as possible. That was their biggest challenge. And then, and they were all running it on top of, again, EKS, and they used a lot of spot instances, again, cost being a big factor here. They used EKS and then used a microservices architecture where, again, highly decoupled, spread out across the globe, and to be able to deploy that in a matter of weeks, in a matter of hours from where they were originally, but it was running in 2 weeks. Delivery Hero, this is primarily a delivery service, and they were really looking to cut costs, right? It's a very, very tough competitive environment, and they have to be at the lowest cost. And they basically transitioned their Kubernetes clusters to run only on EC2 instances. So essentially, what I talked about was the whole unused EC2 capacity at a huge discount, and it was really a huge big difference for them. They were able to reduce their cost tremendously. Cora, I'm sure people are well aware of this. It's a whole question answer website. It has about 300 million unique visitors every month. So here the biggest challenge was, how do you operate the API servers, the admin, the control plane of Kubernetes? They were using kops in the past, and then they found that if they have to all of the administrative activities to upgrade the control plane, to do any kind of maintenance activity, it used to take like weeks to hours. If you have a big environment, and especially if you're trying to serve like 300 million unique visitors, that gets pretty complex. And again, that is a lot of it's not just work. It's pretty sophisticated work that requires fairly significant high skills for people to manage that and maintain that. So moving from there to EKS, where everything is managed by AWS, it's a managed service. So we manage all of those activities, all those upgrades, all those administrative functions that typically happens with the control plane, high availability, resiliency, and so on, is all managed by EKS, by AWS, right? So that's the whole advantage of using a managed service, and they found a significant difference and advantage in using that. Just a quick high-level view of how what all the different components they were using, and essentially what it boils down to is the EKS in a control plane, the EKS Kubernetes master that they talk about here. That's really where the biggest pain point for them was. All the other pieces here was all well automated. They understood. No issues with all of that. Their big pain point was really the Kubernetes control plane here, and they were able to solve that with moving to EKS. HSBC, another financial company that basically created a multi-tenant platform to run their mission-critical containerized applications, right? So it's not if we have customers across the spectrum, depending on whether it's financial, energy, you name it, retail, advisory, and so on. And obviously financial companies are heavily regulated. Security is a big concern for them. So what HSBC really came up with here was to come up with an architecture based again on EKS, where they basically just transitioned the management of the control plane, again here the API server, the multi-AZ, the backups, and so on, to EKS, and then they added on took on all the security features of things like of Kubernetes, and then were able to bolt it onto EKS. Here is a high-level view of it. So they were able to basically they took a multi-layered approach. They had security at the Kubernetes API layer, things like RBAC and audit logging, namespaces, service accounts, resource quotas, network policies. Then they had at a container runtime level, which was basically at an operating system level. They used SE Linux, container image download management, man-in-the-middle attack on that. And then they also took advantage of what AWS offered, things like control plane logging that EKS offered, or endpoint access, like both public and private. You can, be completely private for an EKS endpoint, where nobody from the internet can have access to it. And of course, even if you have access, it's available on the internet. It has IAM roles to be able to securely, authenticate, and in terms of who can access that endpoint. Then you had ECR image scanning, and then other, and then IAM roles for service accounts, essentially, IAM roles for pods, right? Which is not just, so we have always had for EC2 instances on which the containers run or the pods run. Now we have also introduced the IAM roles for service accounts, which uses service accounts, and we have integrated IAM roles with that. And that's done it at a pod level. So obviously it gets more granular in terms of security. Okay. So here, iRobot is another variation. I just wanted to show, this was another company completely different from Babylon that we looked at, but again, using Kubeflow on EKS to really run, power, add machine learning capability to their iRobot and all the data that comes in, how to, rapidly, create new models, get the data in, and to be able to run it across on-prem and cloud environments. And the biggest piece was really kind of abstracting that whole complexity of the underlying infrastructure, with the combination of Kubeflow on EKS, basically gave them, not worrying about the containers itself, what the underlying infrastructure was, how to manage it, maintain it, and Kubeflow also helps, plug and play all of these other machine learning and workflow components to it. So how are the customers building it? So what I wanted to talk about here quickly was, what does EKS offer, right, that makes it so attractive, especially when you're running it on AWS. You get the, if you're on AWS, obviously VPC is a very, very important concept that you adhere to. That's one of the very powerful features that AWS gives you at a network level. So you have your container level VPC networking. It provides you upstream Kubernetes APIs in ecosystem. Whatever you have with native Kubernetes is available to you in EKS. Essentially, it is Kubernetes, right? You have managed nodes and Fargate. So we didn't, we only talked about the control plane in the past, where we are managing all the control plane, but we also have on the data plane aspect of it. So we have the whole managed nodes where we will manage the EC2 underlying EC2 instances for you. So you still have control over the instances, but we will manage the administrative, the OS upgrades, and so on. Then Fargate is essentially, it's all serverless containers. We manage all the infrastructure for the containers for you. So all you have to do is worry about the code. You just deploy the code. We will manage the underlying infrastructure for you. Integration with the rest of the AWS platform, which is again a huge plus. CloudWatch metrics, again, monitoring, observability, that's huge. That's a pretty big, important aspect. Security, reliability, availability, all built into it. With our multi-AZ implementation, you get all that built in. Windows containers, obviously Windows is a big part of it. People are containerizing their Windows applications, quite a few, and we have support for that. And then we already talked about Fargate. So these are the 4 tenets on which EKS was built. It has to be production ready. It has to support production applications. It has to be native and upstream, right? It has to support native and upstream Kubernetes, which it does. There is no forking by AWS. What you see in Kubernetes is what you get. You can just run Kubernetes applications as is on EKS. We contribute to the open source software, open system software. And we have a lot of our the CNI networking and IAM authenticator and so on. We have contributed actually back up to Kubernetes. And then finally, you have the AWS seamless integrations that goes on with it. Flexibility is the biggest piece of this. Again, with EKS, you get the flexibility of Kubernetes, right? That's why people choose Kubernetes for its vibrant ecosystem and community, right? And it has open source APIs and broad flexibility. EKS just provides you the same thing, except on top of that, it just lets you takes away the undifferentiated management and the workload and the time that you want to spend on the control plane. So here is the high level diagram of where how it all fits in. Like if you were to look at this, you have EKS, it is running on Fargate or EC2, and then you have the service mesh. You could have Istio, it supports Istio, Linkerd, but we also have App Mesh, right? So if you look at it, every piece has an AWS component. You can choose to use EKS and all of AWS components, other AWS services, right? Or you can mix and match, and you can choose to bring in whatever you're using, whatever you're comfortable with. We will support that. It'll all work in that ecosystem along with the EKS. We have Prometheus, Grafana, again, native Kubernetes tools. And you have, obviously GitHub. We could do code commit or Jenkins, code build or code deploy, and so on, right? Or ECR with Docker Hub. So just gives you the flexibility, you can plug and play whatever you're using today, with your Kubernetes applications, you can just be able to you'll be able to just take that and move it and use it with EKS. We have managed service of Prometheus. Just wanted to highlight that just came out. So again, managed service being we manage all the infrastructure for you. So you have the exact same capability of Prometheus as you were using earlier, but we manage all of that, underlying infrastructure aspects for you. Same thing for Grafana. We have the same absolute thing. Managed service, manage everything, the infrastructure for you, the scalability, the availability, security for it, but no change in terms of your usage. And then finally, you have, apart from EKS, now you're able to run it in hybrid mode. We had Outposts, which was essentially running in your data center, and you could run EKS on it. Now you have these new components, EKS Anywhere or EKS Distro, that you can actually deploy EKS onto your own on-prem or other clouds, wherever you want to use, just deploy it on that, and you can actually manage it through your EKS console itself. So that's a very, very powerful feature that we have now that we're trying to get that whole hybrid infrastructure, making sure that it is seamless between how you operate in AWS, and the experience is exactly the same, whether you're doing it on-prem, other clouds, or AWS from an EKS perspective. So that's in concluding today's presentation. Basically,